All right, boys and girls. From today's assignment, I want to just give you a little bit of a push in the right direction for problem number 3. And the real issue here is trying to determine what to use as an abundance number for the last isotope of lead, lead 208. All right, so let's see what we have. Lead 204 as an abundance of 1.40%, which is a decimal 0.0140. We write them as decimals. Now the next two isotopes, lead 206 and lead 207, we're told have the same abundance. We're just not told what it is. So you could just say they're both X and X. And then here's the hard one. Lead 208. What is it? We don't know. All right, let's call it some other variable y. Now, the real issue here is trying to express this variable y in terms of x. All right? And we can do that. And let me show you how. These 4 percentages must add up to 100%, which as a decimal is equal to 1. Equals 1 as a decimal. So let's just write this equation out this way. This number plus this number plus this number plus this number equals 1. 0.0140 plus x plus another x plus y is equal to 1. All right, now let's go ahead and subtract 0.0140 from both sides. And then over on this side, it's just be x plus y, but I'm going to combine the x's, so I'll get 2x plus y is equal to 1 minus 0.0140. It would be 1 minus 0.0140. That's going to be equal to 0.986. And if you think about what we've got looking at us right here, this sort of makes sense. 2x plus y, this right here, these two x's and this y must make up 98.6% of the abundance of these 3 bottom isotopes if we know this top one is 1.4%. Right? It's 1.4%, and then this other 98.6% gives us a total of 100%. Right? That's really what this equation is telling us. But again, we want to solve this for y because we want to get y out of here and use some other expression that has x in it. So we will take this equation here and subtract 2x from both sides. And we'll get y is equal to 0.986 minus 2x. So back here. And let's clean this up a little bit. Instead of y, this is going to be 0.986 minus 2x. Okay, good enough? That's just the beginning. Now what we have to do is use these abundances to construct another equation that's going to allow us to solve for x. So there's another equation here that we could write that tells us that the atomic mass of lead is simply the weighted average of the masses of all the individual isotopes. All right, so it's going to be the mass of lead-204 times its abundance, mass of lead-206 times its abundance, the mass of lead-207 times its abundance, and then the mass of lead-208 times its abundance. So what is the mass of lead-204? When we look on our paper, it's 203.973. 203.973. And that's going to be multiplied by its abundance. So we'll put that in parentheses and we'll call it 0.0140. To that, we're going to add the next isotope, its mass times its abundance. Well, what's the mass of lead-206? It's 205.974 times X. All right, that's as far as we can do. Take that right now. Then to that, we're going to add the next mass times abundance for lead-207. It's the mass of lead-207. It's 206.976 times its abundance, which is X. So times X plus the mass of this times the abundance. So the mass of lead-208, which is 207.977 multiplied by, now here we got a big mess. This is going to be the hardest term in the equation to deal with. And maybe you could see why. We have to expand this term by doing a distribution. 207.977 multiplied by 0.986. And then we have to multiply the 207.977 times the negative 2x. So we have to distribute that multiplication to expand this term. Okay, so let's keep that in mind. So, atomic. Oh, by the way, we do know the atomic mass. So we could plug in for this too. Let's go back and read it here. This is right here. If you know the average atomic mass of lead is 207.2 AMUs. All right, calculate all the abundances. I just want to throw that in there. So we'll be able to write this. The atomic mass 207.2 is equal to, and now we have these four terms. So what is now, here's the pain in the butt equation, right? We're going to have to distribute this. So let's do the first term. 207.977 times 0.986 gives us, I'm going to move it down here, 205.0653. I'll leave it that way. All right, so that's that term, this multiplied by that. Now I have to do this term. There's a minus sign here, so it'll be minus, and then it'll be 207.977 times 2x. So 207.977 times 2, that'd be 415.954x. So, there we go. They were teaching all that great algebra stuff for the past couple of years for very good reason. Now we've got ourselves a nice, interesting algebraic equation. We have to solve for x, and that'll get us our answers up here. It'll get us directly the answers for the abundances of the 206 and 207 isotope. And then to get the lead-208 isotope, we'll just have to substitute in x here, and then do the 0.986 minus 2x arithmetic to get our final answer. But I think I'm going to leave it right there and let you ponder the solution to this equation.